Hey guys, this is another example of an input-output table. Okay, this one is actually going horizontally. So the other video that you're going to be watching is going to have a small anchor chart like this at the beginning of the video as well, but it will be have input-output tables that are vertical. Okay, so remember when we're looking at these, then sometimes we're trying to find the unknown number. We're trying to find the relationship between the two items, or the two things that we're talking about, to find the answer or to find the blanks. Okay, to fill in the numbers. Or sometimes they'll give us a filled out table and we need to look at that information and find out what the relationship is and find out what the rule is, okay? So you can always go back and pause the video or rewind it, go back to the beginning and pause it and be able to look at this video or this poster to see while you're doing your work this week, okay? So this might help you do all that. So this one, our relationship for the unknown number is finding the number of scoops and the cups of water, okay? Because this is recipes for lemonade. So that's our titles, we're making lemonade. So the number of scoops of probably like a flavoring, okay? And then the number of, it says lemonade powder right here. So, and then to the cups of water, okay? So for 1 scoop, I need 3 cups of water. 2 scoops, I need 6 cups of water. 3 scoops, I need 9 cups of water. 4 scoops, I need how many cups of water? Well, I need to find out what the relationship is, okay? So pause the video and look through this poster and see what you're looking at and see if you can find the answer. Okay, so let's look at our very first problem here. We have a store is having a sale on books. The sale price of each book is $6 less than the regular price. The table shows prices of different books at the store. So we have a regular price and a sale price, and those are the two things that have a relationship in here. So over here, I'm going to put the regular, and I'm going to have the sale. And you see that this one is going horizontally. So I'm going to go ahead and kind of put in my table here, put in some numbers, okay? So think about this. When you buy something at a regular price at the store, so let's say you go to Walmart and you buy a pack of Skittles, okay? When you buy that pack of Skittles, there's a set price of it. Let's say it was $1, okay? But if it's on sale, that means I can get it at a cheaper price. It's going to be less than the regular price. So when we're looking at our tables and we see that the sale price of each book is $6 less than the regular price, then I know that my sale price needs to be smaller than my regular price. Because if something's on sale, I definitely don't want to pay more than what the regular price is, okay? So if we're looking at that based on that information, if I look at F, it says the regular price is $12, but the sale price is $18. Regular price is $19, sale price is $25. Regular price is $26, sale price is $32. Regular price is $33, sale price is $39. Does that make sense with what we just talked about, knowing that if something's on sale, I know I'm going to get it cheaper? Well, no, it doesn't. So I know that F is a false statement because my sale price cannot be more expensive than my regular price, okay? Remember, when something's on sale, I get to buy it for cheaper, okay? So let's look at G. Regular price is 18, sale price is 19. Okay, that's looking better, okay? Regular price is 36, sale price is 34. Okay. Regular price is 36, sale price is 6. Okay, well, in all of these 3 options, I know that the sale prices are less than the regular prices. So I know that one of those 3 might be my answer choices. So let's go back up here to the information that we know about this problem. The sale price of each book is $6 less than the regular. So if I know the regular price and how much of a discount, how much of on sale am I getting? Well, 6 less than. If I'm doing less than, the 6 less than the regular price, I know I'm subtracting the $6. That's going to give me my sale price. So this is my formula that I'm looking for. So let's say the regular price was $12. Well, regular price minus $6. 12 minus 6 would be 6. So I know my sale price would be 6. Okay, that's just an example of one. If I was going to do $15 for my regular price, 15 minus 6 would equal my sale price. So what is 15 minus 6? Well, that's 9. Okay, so do you see how I've made and created my own table based on the information? So now I can look at these option choices and see which one has a rule and a formula of the regular price minus $6 to give me that sale price. This is our input. Our rule is the minus 6, and our output is our sale price. Okay, so let's look. 18 minus 6 is that 12. Okay, 25 minus 6 is that 19. 32 minus 6 is that 26. 39 minus 6 is that 33. Well, I really can't do that in my head, so I'm going to have to do some work. 18 minus 12, 8 minus 2 is 6. Okay, so I know that this minus 6 gave me 12. The 18 minus 6 gave me 12. 25 minus 19. I'm looking for what the difference is between these numbers to see if it's going to be the $6. So 5 minus 9, I can't do that, so I need to go next door. 2 becomes a 1, and this 5 becomes a 15. I regrouped that tens to go over to the ones place. So 15 minus 9 is 6. So I know 25 minus 6 gave me 19. 32 minus 26. 2 minus 6. I know again I can't do that. My bigger number is not on top. 3 becomes a 2. 2 becomes a 12. 12 minus 6 is 6. So again, that one would be correct. Okay, and then the last one is 39 minus 33. Well, 9 minus 3 is 6. Well, each one of these regular prices minus 6 gave me that correct sale price. So this one is hopefully going to be my answer, but I don't want to just go ahead and guess that with just looking at two different ones. I want to go ahead and check these. So 36 would be my regular price, and 34 is my sale price. Well, what's the difference between 36 and 34? I can count backwards by 2 and know that minus 2 would be 34. Well, is each book $2 less than the regular price? No, it's 6. So I know that this one is not going to be correct because this one was minus 2, where this rule up here was minus 6, which is what I needed. So let's look at J, the last option here. Sale price is 36. Sale price is 6. Now that's a big jump. 30 to 5, 24 to 4, and 18 to 3. Well, I don't think they're subtracting there. To me, that's such a big jump, and I know that those numbers have a relationship because I know my 6 tables, okay? So I know 36 divided by 6 equals 6. 30 divided by 5 equals 6. 24 divided by 4 equals 6. And 18 divided by 3 equals 6. Well, what did they do each time? They divided, okay, and got 6. Well, but it doesn't say that it's divided. It says a total amount of $6 less than. So this one is the rule would be divide by 6. That's not what I want. I definitely want my subtracting 6. So G would be my answer for that one. Okay, here's one more problem for us. Mr. Morales gives bonus points when a challenge question on a test is answered correctly. The table shows the relationship between test scores before and after Mr. Morales gives the bonus points. Okay, so if we look at our table quickly before we go over these option choices in our question, we know that the test scores, that's the title of our table, and what two things have a relationship? The test scores before the bonus points and the test scores after bonus points. Okay, so look at these numbers and what kind of pattern are you seeing between these numbers? Well, when I look at it, I see that the bonus points after, the test scores after the bonus points is a higher number. Well, that does make sense to me because if let's say I make an 83 on a test, well, if my teacher is giving me bonus points, then I'm going to make higher than an 83 because I got one of those challenge questions correct. So it makes sense that my test scores after bonus points is going to be a larger number, okay? So we have test scores before bonus points was 77, but after the bonus points, it became an 81. So the person actually made a 77 on the test, but because they answered a challenge question correctly, they made an 81. 79 made an 83. An 81 test score made an 85. 83 became an 87. Okay, so that is the table that we're working with. So now my question sentence says, which of these describes the relationship shown in the table? So it has me a filled out table, and I'm going to go and read through these to see which one of these is true or false. Remember, our after bonus points is always going to be the larger number because that's what makes sense. If I get a challenge question right that I'm getting bonus points, my test score is not going to go backwards and get worse. It's going to get better, okay? So keep that in mind when we're reading these. The test score before bonus points, now that's before bonus points, minus 2 equals the test scores after the bonus points, okay? So is our test score 77 minus 2 going to give me 81? No, it's not, because minus 2 is a false statement, okay? Remember, we just said we don't want to go here and take away points to get our bigger number for our bonus points. If I get a bonus question, I'm getting more points. I'm getting a better grade. So B, the test scores before bonus points, we're still looking at before first, minus 4 equals the test scores after bonus points, okay? Again, minus 4, we don't want to have to subtract when we get a bonus question right. So this minus 4 is also false. Okay, so let's look at C. The test scores before bonus points, our first table, our input here, plus 2 equals our test scores. Well, does 77 plus 2 equal 81? Well, 77 plus 2 actually equals 79. Let's just check it just in case. 79 plus 2 equals 9 plus 2 is 11, 7 plus 1 is 8, 81. Well, 79 plus 2 doesn't equal 83, so plus 2 is also false. And I've checked it. It doesn't make any sense of plus 2. So the challenge question is not worth 2 bonus points. So let's hope that D is right. Since I've gone through and I've proven my work, I really hope that D is my answer. The test score before bonus points, we're still looking at that input table first, plus 4 equals the test scores after. Well, let's try it. 77 plus 4. 7 plus 4 is 11. Carry my 1 up here. 7 plus 1 is 8. Well, 77 plus 4 does equal 81. Let's try it with the next one. 79 plus 4. 9 plus 4 is 13. 3 carry a 1 up here. 83. 79 plus 4 does equal 83. 81 plus 4 does equal 85. 83 plus 4 does equal 87. So that means that each challenge question equals 4 points. So plus 4 is a true statement, and D would be my correct answer. So if I wanted to write a formula for this, now that I have the correct rule in the relationship here, I would say the test scores before plus 4 equals my test score after the bonus. And that 4 points, that plus 4, is going to be our challenge question. So hope this helps you guys this week. Have fun with your input-output tables. Make sure that you show your work, and don't be afraid to actually really draw out some stuff and do some math, okay? Have fun. If you need any help with any of your problems, let your teacher know, okay? Bye.